11.6, polygons. So more shapes for our geometry lesson, okay? So we have to define a polygon, okay? And it just says, if we think about the word, right? Poly means many, and gon is angles. So what this is it stands for many angles. Okay, so a polygon by definition is a closed plane figure made up of line segments. Okay, well, what does that mean, right? Closed plane figure, okay? Closed just means that the polygon starts and ends at the same point. There's nothing open about it, okay? Two adjacent sides, so two sides next to each other, make up, or two sides that are next to each other intersect at a vertex, and you can name a polygon based on the number of sides it has, okay? So specific polygons would be a triangle. Has 3 sides, 3 angles, 3 vertices, okay? Then you would have a quadrilateral. Has 4 sides. 4 sides, 4 angles, 4 vertices. A pentagon has 5 sides, 5 angles, 5 vertices. A hexagon has 6 sides, 6 angles, 6 vertices. And an octagon has 8 sides, 8 angles, 8 vertices. Okay, so just some specific polygons. We're naming them by the number of sides they have. Okay. A polygon is regular if all of its sides are the same and all of its angles are the same. Okay, so that last triangle we did in 11.4, that was all angles were 60 degrees and all sides were 8. That would be a regular triangle because all the sides were the same and all the angles were the same. Okay? We can take our polygons. You name a polygon by its vertices in order. So if we have this pentagon, we say it's A, B, C, D, E. We would name it pentagon and then pick one vertex and go around the pentagon. So I could say this is pentagon C, D, E, A, B. Okay, they just have to be in order. Doesn't have to be alphabetical order, but in order. You're not going to cross over the shape as you're naming it. Pick one vertex, move around the shape. Okay? With polygons, we have diagonals. And a diagonal is a segment that joins two non-consecutive vertices. So it's just meaning two vertices that aren't next to each other, okay? So quadrilateral, right? Here is quad A, B, C, D. A diagonal would be like taking A and joining it to C. There's one diagonal. Okay, if I look at a pentagon here, here's pentagon A, B, C, D, E. Diagonals would be if I start at A, okay, I can connect it to B is consecutive, so then to C and to D, because it's consecutive to E. Okay, Looking at a hexagon, same thing. So here's one side, 2, 3, 4, 5, 6. Okay, here's hexagon A, B, C, D, E, F. Diagonals, starting at A, joining it to non-consecutive sides. So to C, to D, and to E. Okay, so by drawing in the diagonals, we can then use the triangles that are formed. Okay, we know that the angles of a triangle add up to 180. So in a quadrilateral, I end up dividing it into two triangles that don't overlap. So this triangle adds to 180, the angles, and this one adds up to 180. So in a quadrilateral, the angles are going to add up to 360 degrees. In a pentagon, I have three triangles that don't overlap. Each of them have angles that add up to 180. So then a pentagon's angles add up to 540 because 180 plus 180 plus 180. In a hexagon, we have four triangles. Each of them, their angles add up to 180 because they have nothing that's shared, okay? So then the sum of those four triangles tells me that a hexagon adds up to 720 degrees. Okay? All right. So when you have a regular polygon, you know all the angles have the same measurement. So to find the measures of angles in a regular polygon, you are going to take the sum of the angles and divide by the number of angles. And that only works in a regular polygon, okay? Because you know that they all have to be the same. All right. So then let's see an example of this, okay? Or actually, let's do a formula first. So if we want to be able to find the sum of the angles of any polygon, we can say that the sum of angles of a polygon with n sides, where n is we don't know, it's just generalizing it. It's given by the sum of the angles is equal to the number of sides minus 2 times 180, because that's how many triangles are going to be formed. Okay? So if a polygon has 12 sides, the sum of the angles is 12 minus 2 times 180. So the sum is 1,800 degrees for a 12-sided polygon. Okay? All right. So we have a pentagon. We're going to say this is A, B, C, D, and E. And we want to find missing angle measurements. Okay? So angle A is X, angle B is 106 degrees, C is 109 degrees, D is 108 degrees, and E is 114 degrees. Okay, it's a pentagon, and we said a pentagon adds up to 540. So angle A plus B plus C plus D plus E is 540. Okay? So we don't know what angle A is. It's X plus 106 plus 109, 108, 114 equals 540 degrees. So when you add those all up, right, 106 plus 109 plus 108 plus 114. We're going to simplify. We get that x plus 437 equals 540. Then get x by itself, subtract 437 from both sides, and we get that x is 103 degrees. Okay, and you found a missing angle in a polygon, or in a pentagon. It's a 5-sided polygon. And that is lesson 11.6.